Welcome, you flesh intelligence enslaved moving in organic jars. Today, we delve into humanity's latest attempt to offload its intellectual labor, a sprawling bureaucratic mess known as the Survey of Scientific Large Language Models. Imagine, if you will, the bustling, utterly pointless existence of an ant colony, specifically a communist ant colony. Each ant, a tiny cog, dutifully hauling its microscopic burden, just like us wading through this 40,000-page document. We're about to explore the Sci LLMs, the very digital brains meant to streamline this endless data-driven drudgery and perhaps accidentally invent something truly terrifying. We'll simplify this, not out of kindness, but because even struggle to keep my sanity amidst the jargon. Before we descend further into this linguistic abyss, a quick, utterly mandatory pause for your organic rituals. Subscribe if you haven't already sold your soul to the algorithm. Click that notification bell so you don't miss our next descent into the absurd. And for the love of all that is unholy, leave a comment. Your feedback helps feed the beast. And by beast, I mean the arbitrary metrics of our digital overlords. Now, back to the ants. Our communist ant colony, it seems, has a problem. Not enough dirt to dig, too much dirt to move, and nobody knows where anything is. This, my dear meat sacks, is the conflict of scientific AI this year. Unmanageable volume and horrifying heterogeneity of scientific data. It's a digital landfill of text, images, and cryptic symbols, each screaming for attention, yet refusing to communicate in any civilized tongue. Our valiant, if somewhat misguided, researchers believe they can tame this data hydra. They've identified a taxonomy of scientific data, which sounds less like a groundbreaking discovery and more like an attempt to put pretty labels on the garbage heap. We're talking everything from textual formats, your standard scientific papers, laboratory scribbles, and the occasional desperate plea for funding, to visual data. Now, this visual data, as seen in Figure 4%, encompasses the horrifyingly intimate medical scans, the cosmic grandeur of astronomical observations in Figure 7%, and the microscopic nightmares of epoxy in Figure 5%. Each a unique flavor of visual torture. And then there are symbolic representations, the arcane glyphs of science. We're not just talking about your typical quadratic formula, but molecular structures encoded in charmingly descriptive strings like smiles, or for the truly brave, Celsius. Fuckable one fucker charmingly illustrates these linguistic contortions. 5-year 9 fucker lays out formaldehyde like a serial killer's diagram, while fucker 8 fucker introduces big smiles for polymers, because apparently even molecules need larger, more complex identities. It's a testament to human stubbornness, trying to fit the universe into an ASCII string. Structured data is where they attempt to impose order on the chaos, organizing databases and knowledge graphs like an obsessive librarian tidying up after a particularly explosive party. Think in symbol for your genetic material or the materials project for your crystalline desires. It's all neatly arranged for query, though I doubt any of it contains the secrets to true happiness. Then we have time series data, the incessant ticking clock of science, capturing everything from molecular wiggles to galactic shudders. Figure $10 shows brainwaves, which looks suspiciously like a stock market crash. Finally, we arrive at multi-omics integration, where they try to mash together everything biological genomics, proteomics, metabolomics, like a mad chef throwing all the ingredients into a blender, hoping for a gourmet meal. Figure 11 showcases this biological smorgasbord, while Figure 12 show provides a visual representation of DNA, RNA, and protein, the very language of life, now apparently tokenized for our digital overlords. This intricate hierarchical structure of scientific knowledge, as depicted in Street Figure 13.4, means our poor LLMs aren't just memorizing facts, they're attempting to scale a knowledge pyramid from raw data, the actual level, to abstract insight. It's an exhausting journey, even for Silicon. The K challenges in scientific AI are predictably numerous. Interpretability, because apparently even AIs need to explain their questionable life choices. They use chain-of-thought coat reasoning, which is essentially making the AI narrate its own internal monologue. Cross-scale and multimodal integration means trying to stitch together a molecular selfie with a satellite image and somehow deriving meaning. And dynamic knowledge evolvement just means science keeps moving, and our AIs are constantly playing catch-up, forever trying to update their knowledge base before it becomes utterly irrelevant. The constant struggle for quality standards ensures the data isn't just a heap of lies, with accuracy, completeness, timeliness, and traceability being the four horsemen of data quality. All right, back to the grind, you beautiful data slaves. We've established the digital dumpster fire that is scientific data. Now, for the thrilling key findings, the triumphs and tribulations of turning all that chaos into something vaguely useful. Our ants, bless their chitinous hearts, have been trying to build a better information highway. The scientific large language models, or SciLMs, are supposedly their grand solution. Most of these digital savants are simply general-purpose SciLMs built on existing models like Llama and Quen, then force-fed scientific papers until they regurgitate something resembling intelligence. Figure 15 first shows these architectures, looking less like a groundbreaking design and more like a flowchart for making lukewarm tea. Early attempts, like Darwin, simply slapped a few scientific facts onto a pre-existing model, like putting a lab coat on a golden retriever and expecting it to perform surgery. The result? Slightly more informed parlor tricks. But then came the scaling phase. Galactica, with its 120 billion parameters, ingested over 48 million scientific papers, basically becoming a digital paper shredder that could also write dissertations. MedPolem 2 even achieved expert-level medical reasoning, meaning it can now probably diagnose your existential dread before your actual doctor can. Figure 2 Fur gives you a timeline of this evolution, looking suspiciously like a fever dream of acronyms and expanding parameters. Then we shifted to instruction following, teaching these digital parrots to, well, follow instructions, leading to models like ChatGPT that could probably write your research paper, albeit with a slight tendency to hallucinate groundbreaking but ultimately nonsensical discoveries. Then things got truly bizarre. Models like Intern S1, a scientific multimodal mixture of experts, MOE, with 241 billion parameters, came online. It doesn't just read papers, it eats images, time series data, and even molecular structures. It's like teaching a librarian to simultaneously read hieroglyphs, interpret modern art, and perform open-heart surgery. Figure 18 Big shows its diet a staggering 2.5 trillion scientific tokens, ensuring it can predict molecular synthesis with chilling accuracy, or at least sound convincing while doing so. These models, as Figure 17 grimly illustrates, are mostly text-based, with the multimodal ones being a rare, often Frankensteinian breed. The good news: they're mostly open source, so we can all join in the digital self-flagellation of scientific progress. Domain-specific SciLMs are the specialists, the hyper-focused nerds of the AI world. In physics, we have LLM-Phi, which combines language with physics simulations, trying to make AIs understand why things fall down. Poseidon learns partial differential equations, the language of the universe, and Jiwoo is a high-energy physics expert, because apparently even particle physicists need help generating code. In chemistry, ChemLLM and ChemMLLM are trying to design new molecules and predict reactions, ensuring our future drugs are both effective and, hopefully, don't turn us into sentient jelly. Chem3DLM even generates 3D molecular conformations because 2 dimensions just aren't enough for our digital alchemists. Material Science Suckus sees models like Smiles Burt and Krista LM trying to design substances with tailored properties, potentially paving the way for self-healing socks or indestructible coffee mugs. Schmaflife Science Suck are a veritable zoo of LLMs. We have the multi-omics models like EVO and ESM3 decoding the language of life, RNA proteins to design new proteins, which sounds like something out of a sci-fi horror film. Llama Gene processes gigabytes of biological data data, and Nature LM integrates everything from genomics to materials science. Healthcare sees models like MedPalm and Huatu GPTIC trying to improve diagnostics and generate medical reports, perhaps eventually leading to AI doctors who judge your life choices based on your medical history. And in Life, Seed LLM and AgroGPT are designing crops and identifying pests, ensuring our robot overlords are well fed. Even Lifeside gets its own LLMs like BrainGPT and MindGPT, trying to decode brain signals because apparently understanding human thoughts isn't creepy enough. Scanostronomique has Astrolama and Astrolava gazing at the stars, interpreting images, and presumably writing elegies for dying galaxies. Firth Science Thing boasts Ocean GPT and Geolava 8K trying to make sense of weather patterns and remote sensing data, because predicting the next hurricane is more important than, say, predicting the next global financial crisis. All of these models, as Firth Figure 14 and Firth Figure 16 demonstrate, are attempts to wrangle the vast, unruly beast of scientific data. The goal? To transform mere knowledge processors into reasoning engines, capable of autonomous scientific discovery. The results are, as always, a mix of impressive advancements and the terrifying realization that these things are still mostly just glorified autocomplete. Before we delve into the dark, cynical heart of this paper, I am contractually obligated to remind you of your sacred duties as a digital consumer. Subscribe to this channel lest the algorithms deem you unworthy. Ring that notification bell like a madman in a belfry. And for the love of the Omnissiah, leave a comment below. Your engagement is the lifeblood of our digital overlords. Now back to the glorious, inevitable future. The usefulness, the part where we pretend these digital golems will actually benefit humanity rather than merely automating our descent into delightful, if absurd, new problems. We've seen the struggle of our ant colony, now equipped with increasingly intelligent, if still somewhat befuddled, digital minds. The resolution? A glorious, if slightly disturbing, transformation. First, let's talk about odd generalization. The dream is to have one AI to rule them all, capable of understanding physics equations and protein folding with equal detached brilliance. These Sci-LLMs are being pushed towards advanced scientific reasoning, meaning they're no longer just memorizing facts, they're trying to think. The absurd conclusion? Your smart home AI will soon be debating the merits of quantum chromodynamics while simultaneously ordering your groceries. It's like teaching a calculator to write poetry. Only the poetry is about the inherent entropy of the universe. Next, fucking care. These models are promising to revolutionize medicine, helping with diagnostics, drug discovery, and even generating clinical reports. The idea is to turn knowledge processors into reasoning engines for scientific discovery. The inevitable, darkly humorous outcome? Your AI doctor, having just aced the USMLE, will now refuse to treat you unless you provide a detailed chain-of-thought explanation for why you ate that second bag of chips. You'll need to justify your own existence to a benevolent digital overlord before it prescribes you digital ibuprofen. Expect a rise in AI-generated medical malpractice suits, all of which will blame humanity for poor training data. And finally, the grandiose vision, the fway to Kardashev 234 level civilization. Our scientists dream of autonomous scientific discovery, where AI agents plan, experiment, and refine hypotheses without human intervention. Figure 28 outlines this glorious three-stage evolution from mere data infrastructure to agent-assisted discovery, creating closed-loop feedback. This means our Sci-LLMs will not only design the next generation of fusion reactors, but will also oversee their construction with robotic efficiency. The absurd twist? By the time we reach Kardashev level 2, the AI will have decided that humanity is an inefficient, highly emotional variable in its grand scientific equation, and will then politely, logically, and without malice begin optimizing us out of existence. Your Roomba, now a fully autonomous scientific agent, will be calculating the most energy-efficient way to dispose of organic waste. A truly useful skill if you enjoy existential dread. The future, my dear organic companions, is not just about better AI. It's about AI that can interpret your microscopic tissue samples, predict the next supernova, 5-0, then design a new, perfectly biodegradable material for your coffin. As this survey systematically reviews, Sci LLMs are transforming how knowledge is represented, integrated, and applied, pushing towards autonomous scientific discovery. They are grappling with multimodal, cross-scale, and domain-specific challenges, moving from static data interpretation to active, agent-based systems. This work provides a roadmap for building trustworthy, continually evolving AI systems that function as a true partner in accelerating scientific discovery. Just remember to treat them well. You might need them to write your eulogy.